Good morning. Today, in this lab class, we are going to see a realization of the gates, namely AND, OR, NOT, XOR, XNOR, and NOR. Okay, using universal gates. Using universal gate. So we have two universal gate. Okay, we have two universal gate, namely NAND or NOR. Okay, NAND or NOR. Okay. So NAND gate IC number is IC7400. So we are going to realize all the other logic gates, namely AND, OR, NOT, XOR, XNOR, and NOR using universal gate. Using universal gate NAND first, and later we will go ahead with the NOR. Okay, and later we will go ahead with NOR. So as I said, this is the universal gate NAND, and the IC number of NAND is IC7400, IC7400, and it is a 14 pin IC. It is a 14 pin IC, and we will be having 14 pins and 4 NAND gates, 2 input NAND gates in the IC7400. The first thing that we need to see is NOT gate, realization of NOT gate by using NAND gate. Okay, since this is said to be universal gate, all the other gates should be realized with the help of this NAND gate. Okay. So how we are going to see? We know the truth table of the NOT gate. What is NOT gate? 0. If you are giving 0, you need to get 1, and if you are giving 1, and if you need to get 0. And what is NAND gate? You will be giving 2 inputs for a NAND, and no, NAND gate in the sense you will be having a bubble at the output of the AND, that is said to be your NAND. And so if we need to realize the NOT gate, tie these two inputs of the AND and give the input as single input. So you will be having a single input A, so output will be A bar. Okay, output will be A bar. That is how we can realize the NOT gate by using NAND gate. So 0 to 1 and 1 and 0. And the next thing is AND gate. Next thing is AND gate. So realize your AND gate by using your NAND gate. Okay, right. So how you will realize, if you have a NAND gate with 2 inputs, if you have NAND gates with 2 inputs A and B, so what will be your output? It will be AB the whole bar, am I right? Or AB the whole bar. But we need AB as output, because for AND gate, if A and B are the inputs, AB will be the output. So if we need AB, again I need to use what? A NOT gate. Okay, NOT gate. This is also NAND gate only. Okay, this is also NAND gate only. We are going to use this 7400 only. Okay, we are going to use this 7400 only. So finally you will be getting AB as the output, which is nothing but the output of the NAND gate. We know the truth table of the NAND gate. For both, when both the inputs are 1, your output will be 1. So here, while we are realizing this in the hardware, realizing this type of AND gate in the hardware, how we are going to connect it is, see, we are going to give, let me realize NAND gate with use NAND gate for AND gate. Okay, AND gate realization. Just now we have seen we will be using two NAND gates. This is AB bar, this is AB, and the output is AB. Okay, so let me assume that, see, this is a 14 pin IC. The 7th pin is used for ground. The 7th pin will be used for ground, and for VCC will be the power supply. This will be given as plus 5 volt from the power supply, regulated power supply. Okay, So I will give you the link that in the hardware how to realize the gates, okay, the basic gates. I haven't covered the logic gates, but I have universal gates, but I have covered the basic logic gates. Those link I will give you, just watch down those videos, okay. And so now I need to give two inputs. Let me take the first gate, okay. So here I will be connecting A and here I will be connecting B. So the output I need to connect it to the next NOR gate, next NAND gate, I'm sorry, next NAND gate. So the next NAND gate is 2. So let me tie these two, okay. Let me tie these two. Here from the output I will be taking it and I will be giving it to the input. This is nothing but AB the whole bar, okay, and from this point I will be taking the output. This is nothing but the output of the AND gate, okay, that is AB, okay. So now this AB will be having 4 combinations, 0, 1 or 0 0 0 1 1 0 and 1 1. So how we are going to give this input, okay. 0 0 means it is similar to ground, so these two pins has to be connected to the ground. 0 1 means one should be connected to the ground and other should be given to the plus 5 volt VCC. So this plus 5 volt VCC is a high, okay, it is a high, okay, and 1 0 and again A should be connected to 5 volt, B should be connected to the ground. When both are 1, both the pins 1 and 2 will be connected to 14 and 7, okay. Keep in mind this 14 and 7 will be connected to the power supply and the on the ground of the regulated power supply, okay, of the regulated power supply. And this is how you will be realizing your output. This is how you will be realizing your output. So what I will be doing is finally realizing the output in hardware. How will I do is I will be connecting an resistor, okay, I will be connecting a resistor and then an LED, okay, LED. And then the LED will be connected to the ground, okay. This is for converting this voltage equivalent to your current equivalent. Only then your LED will blink, okay. So for what input your input combinations your this LED will blink? Only for the last input, namely 1 1, okay, only for the last input, namely 1 1. And next thing is nothing but OR gate. So OR gate, again I will be using two NOT gate using NAND gate, okay. This is a NOT gate using NAND gate. So A bar B bar and then again take an inverted thing. So it will be A bar B bar the whole bar, which is nothing but A plus B by we know that this is by De Morgan's law, okay. So next thing is your XOR. XOR will be realized like this. So you will be having a NAND first, AB and AB bar, and that will be given again. So A into AB bar the whole bar and AB bar the whole bar into B, and that will be realized here, which is nothing but A dot B, okay. That will be realized here, that is nothing but A dot B. A it is XOR B. XOR in the sense it is A, the symbol is like this, A XOR B. Is it okay? Okay. The next thing is your OR gate, and again A bar B bar, give it here. This is already discussed. This is OR gate, and the next one it is again NOR gate, okay. NOR gate. So give A bar B bar here, and then you will be getting here the input A plus B. NOR gate is nothing but A plus B the whole bar is your NOR gate. So that can be realized by using 4 NAND gates. So now how we are going to realize this, okay, how we are going to realize this. Let me take this as an example. Keep in mind, let me first go ahead with LTSpice, okay. Let me first go ahead with LTSpice. So let me pick the IC. And the last class itself I said how to take this Z folder. So in that I'll be going ahead with the logic. And 74HC 00 is an AND. Yeah, 00 is an AND. So minus. So how many NAND we need to realize your OR gate, NOR gate? We need 4, right? So let me place it here: 1, 2, and then 3. 4. Okay. So right. And then what about the connections? This one, the first one, second one, and the fourth gate is your NOT gate. So let me tie that first. Okay. And this is also a NOT gate. And then from here I'll be giving the input here and here, and then I'll be giving the input here. Okay, so the connections are over. We need to give the inputs. So for giving the inputs, let me go ahead with the voltage source. So the voltage, I haven't come out of the Z folder. So this is a voltage, 2 voltage sources that I'm going to give it here. Connect it through the wire. Okay, and then ground it. The only thing that is pending is give the label. One is A in input, and then give the input. Later I will rename. Okay, and then one output at the E4 end. Output, and here also let me select output, click OK, and connect it here. Okay, and then this is nothing but BN, right? So BN, here also I need to rename it as BN. Now so what is this? A 0011. So let me take for each combination, let me take 1 milliseconds. Okay, so first for A is 0, 0, 1 and 1. So off time is 2 milliseconds, on time is 2 milliseconds for A. Okay, whereas for B it is off for 0, on for 1 milli. So it is off for 1 milli, on for 1 milli. Okay, so this is regarding your B. So the total time period T for B is 2 milliseconds, and total time period for A is nothing but 4 milliseconds. Okay, and in LTSpice you need to take pulse as the input. In that you will be having an option called T delay. So usually the T delay, if you are not giving delay, if you are giving delay as 0, this A and B initially it will come as high, meaning for A it will be 2 milliseconds on and 2 milliseconds off. So but for us initially we need 0. So for that what we need to do is we need to change this time delay as 2 milliseconds. Okay, as 2 milliseconds. Only then you will be getting initially 2 milliseconds off and later 2 milliseconds on. Okay, for the A I am telling. Similarly for the B. For the B you need to give T delay as 1 milliseconds. Okay, so let me give it. So this is advanced. Right click, go for the advanced, go for the pulse. So initial value is 0, on is 0 voltage. On time is 5, on voltage is 5. When it is 5, when it is on, meaning the pulse has to be 5 volts. Delay I said 2 milliseconds. Rise time 1 nano, give it, because fastly it has to rise with a minimum amount of time. And nanoseconds, 1 nanosecond, and on time is 2 milli. Total time is 4 milliseconds. Okay, click OK. It will come here. So you can place it and here. Okay. And similarly go ahead with B. Go ahead with B. Go ahead with the pulse. And again here 0, 5, 1 milli, 1 nano, 1 nano, 1 milli, 1 milli. Click OK. Okay, and again click here, bring it here. Okay, press escape. Shall we run? So now the total period for viewing your one cycle of input, the total period is 4 milliseconds. Okay, 4 milliseconds. I think this is 2 milliseconds. Okay. So now let me run. Stop time, I will view it for one cycle. So transient 4 milliseconds. Click OK. Okay, right. So right click on it, add plot plane. I need 3. Add plot plane, and I will be adding first add traces in first input. So for 2 milliseconds off, 2 milliseconds on, and then add traces B in. Okay, and then add traces output. Okay, so let me maximize the screen. We are realizing NOR. Okay, we are realizing NOR by using NAND. See the truth table, only for 0 0 it has to be high, for rest all input combination it has to be 1. So only for 0, both 0 your output is high, the rest all the rest all combinations your output is 0. Is it fine? Is it okay? So likewise you just realize all the gates. Okay, you just realize all the gates, namely your NOT, AND, OR, XOR, with the help of your NAND gate. IC 74HC00. Is it fine? Okay, in the same way, how to realize this by using Emona netcircuits. In the last class itself, I said how to go ahead with the Emona netcircuits. So it is, I have already logged in. Similarly, you just log in. You need a NAND gate. Oh, see here you have a NAND gate. First, let me have FSM sequence. Okay. If you are not sure of your remote public SS ID, please note it down. This is your remote public SS. And last week itself I said your username and your password. Password is VITCC. Give your username and then go ahead. And then select as, next one is you need to select as dual NAND, right? Okay. So how to realize this? So the first thing is we need two NAND gates. So let me take it here. Let this be AN. Let me short these two. Oh, I cannot short. Okay, let me connect it to A itself. Okay, it's one and the same. Similarly, let me connect it to B. Okay, and both outputs I connected to the NAND gate. So both the outputs I connected to the second NAND gate. Okay, and this output I need to connect it to the fourth NAND gate. Okay, so now I need to realize the output. So let me give FSM1 in channel A and FSM2 in channel B, and this is the final output. Let me give it in channel C. So let me bring this down. Okay, I will switch off this. Okay, I have removed by pressing the time. This is my output. So let me increase the time base and check. 20 microseconds. Fine, because this is clear. And you can even increase this volt so that it will be much better. So for which combinations you have 1 at the output? For both 0 and 0. For both 0 and 0 I need a 1. So when these two are 0, 0 and 0, I have a 1, but instead I have a 0. I need to tie this and give. to tie this. So what I have done is I have connected here, instead of connecting the fourth NAND gates output, I have connected the third NAND gates output. So let me redo it again for the output alone. That is why it was giving a wrong output. So this one, let me give it here to channel C. Now it should be right. So see, when both the A and B is 0 and the output is 1, for the rest all combination your output is 0. Namely for 1 0 combination, 0 1 combination and 1 1 combination, it is like this. You getting me? This is 0 0 and this is 0 1 and this is 1 0 and this is 1 1. For all the combination this is 0 except for 0 0. Okay, I hope you are clear with this. Okay, so in the same way, realize your XOR gate, realize your OR gate, and realize your AND gate, NOT gate with the help of both LTSpice as well as your Emona netcircuits. Okay, Emona netcircuits. This is regarding your universal NAND gate. So one more gate is also said to be NOR gate, which is nothing but NOR gate. Am I right? Which is nothing but NOR gate, which is nothing but IC7402 is IC number. Okay, and this can also be realized in the same way as like your NAND gate. This is NOT gate realization. How you are going to realize your NOT. So again you need to tie up here and give A as input, A bar will be the output. So this is your OR gate diagram, this is your this is your AND gate, and this is your XNOR, and this is your NAND. Okay, this is your NAND. What we have seen now is NOR. Okay, so here let me simulate this with XNOR. Let us go ahead with XNOR. Okay, for realization using NOR gate. Okay, guys, listen here. I have drawn XNOR. Okay, XNOR by using NOR gate. By using NOR gate. So we have one over the first stage. In the second stage we have two NOR gates. In the third stage we have one NOR gate. So I have connected here like this with the same input previously, because the 4 combinations it has to appear. So I haven't changed the input combination, and only the structure I changed. I have taken 7402 from the XZZ folder logic. Okay, see, it is available here in the logic, in the XZZ folder. Go for the logic, go for 74HC, and 7402 is your 2 input NOR gate. So let me run again. Again I need to get add plot plane, add traces, A in as input, add traces, B in as other input, and add traces, output share. Okay, so let me go ahead this to the maximum, bring it to the maximum. Okay, so here what is the output is for 0 0 it is 1 and 1 1 it is 1, meaning for similar inputs your output has to be 1. So for similar inputs, for 0 0 it is 1 and then for 1 1 it is 1. Okay, and in the same way you need to realize this by using Emona netcircuits too. So let me select dual NOR, it is available. Only dual OR is available. Guys, only in the gate you have a thing called gate medley. Okay, only in that you have 2 NOR gates. That too only 2 NOR gates. I mean only one NOR gate we have in the gate medley. So if I remove, I go ahead, I can have only in the gate medley I have all the gates. Okay, I have all the gates, namely if I'm giving input here, that will be common. The realization of logic gates can be made common here. Input can be made common here. From here I can take it and place it. But I have only one NOR gate. So realization of NOR gate using Emona netcircuit is not possible. Only realization of NAND gate is possible. Okay, realization of all the gates with NAND gate is possible with Emona netcircuits. So the things I have covered today is realization of NAND and NOR gates, meaning realization of all other logic gates using the universal gates NAND and NOR, and I have used LTSpice for simulating your NOR using NAND and XOR using NOR. Regarding your Emona netcircuits, realization of all other gates, namely OR, NOT, XOR, like that can be possible only by using NAND. That is not possible by using NOR. With this I'll stop today. Do your simulation and get your results.